Okay. All right, so take a look here again. We have the quadratic curve here. That's on top. And we have the linear curve that's on the bottom. And we have our interval from -3 to +3. So we're trying to find the area between the two curves here. So here's this area. And as we say, the interval they give us here from -3 to +3, this first vertical line is x is -3. Second vertical line, x is +3. So remember, we're going to draw that approximating rectangle here, that strip, because this helps identify the top and the bottom curve here. So that the area is going to be found by integrating the top curve minus the bottom again, dx, and our limits are going to be from -3 to +3. Okay, so you're going to have to now take the difference of two functions. Now, what that looks like is remember, the top curve was going to be the quadratic, right? Remember that parabola? So you have 3x squared plus 12 minus the bottom curve, which is the line, which is 4x plus 4, and that's dx. So this is from -3 to +3. Okay, so in the middle here, you're going to have some algebra to do. So we're going to have to distribute, and we get the integral from -3 to +3, 3x squared plus 12 minus 4x minus that 4, and just combine your like terms. So we're going to integrate from -3, +3, 3x squared minus 4x plus that 8. So ladies and gentlemen, here's what you're going to have to do to find this area between two curves. Okay, so now you're going to have to use properties of integration, your power rule, right? Find the antiderivative, evaluated at +3 and -3. So this is what we're going to have to do. Okay, so here we go. So let's find the antiderivative here. And here's what we get. 3x cubed over 3 minus 4x squared over 2 plus that 8x, right? And this is going to be really, if we simplify, x cubed minus 2x squared plus 8x. Here's 2. And we evaluate that from x is -3 to x is +3. Okay? So here's the antiderivative function. And so now let's verify that f of 3 is going to be 3 cubed minus 2 times 3 squared plus 8 times 3. This is my first antiderivative, right? Evaluated at 3 minus -3 cubed minus 2 times -3 squared plus that 8 times -3. And that's f of -3 here. So double check to see if we made any mistakes here. So now you get 27 minus 2 times 9 plus 24 here, minus, that's -27, minus 2 times 9 again, minus 24. Bless you. So we'll have 27 minus 18 plus 24, okay? And, you know, sometimes it's helpful to just to keep distributing here. So you'll say that's plus 27. Here's what you're going to look at if we distribute. This is going to be plus another 18, right? And then that's plus 24 here. So it looks like the only terms that cancel are the -18 and +18. So we get 27 plus 27, isn't that 54? 54 plus 48, what do we get? Do you guys know what that is? Is that 102? Okay, notice that's positive. But this is the area that's right in here. That's your area between curves again. That was based on our lecture. So there is a good example of what we're talking about. And as you guys can see, you simply have to perform your integral. Is that right? All right. So take a look at the next question here, right? They want, again, the area between the curves. And as you guys can see, they gave us, oh, let's be very careful here. Area between the curves, between these lines here. Because the interval now that they gave us here, right, is -3, or -1 to +3 here. So let's remember, this is the vertical line here of x being -1. This is that vertical line of x being +3. So they gave us this particular region here. We have to identify again, since how we perform this area. I don't know, how do you guys feel? Do you like the purple, or should we go blue? Purple? All right. So our area will be now between -1, +3. Again, it's the top curve minus the bottom curve. So we have to identify what curve here is on top and what's on bottom. Okay, the black curve is on top. What kind of curve is that actually? Isn't that actually a line? So the top curve here is a line. So it looks like here's my top, right? And the bottom curve is the parabola. So there's the bottom curve. Okay. So let's replace this with what it is. How about if we do it this way? I'm going to say, here's my top curve. Let's do the algebra first. It's 3x plus 8. And your bottom curve is x squared plus 2x plus 2. Is that right? So remember what I'm supposed to do here. I'm supposed to subtract those terms. So I'll have 3x plus 8 distribute and simplify, right? So you're going to end up with, looks like it's -x squared. 3x minus 2x, that's plus x. 8 minus 2, isn't that plus 6? Okay, double check. So I have to integrate from -1 to 3, -x squared plus x plus 6 dx. Okay, so I need the antiderivative function. And let's see, what do we get when we perform that antiderivative? Don't we get what? -x cubed over 3 plus x squared over 2 plus 6x. Is that right? We have to evaluate this from -1 to 3. Antiderivative. So we have to find f of 3 minus f of -1. -1/3, 3 cubed, plus 1/2, 3 squared, plus 6 times 3. Minus -1/3, -1 cubed, plus 1/2, -1 squared, plus 6 times -1. So double check to see if we actually have the right thing, right? We have f of 3, f of -1. Is that what we have here? Are we okay? Do you guys know? So it looks like this is -1/3. I'm not going to simplify in my head. Let's write this down. 27 plus 1/2 times 9 plus 18. That's in the first set of parentheses. -1/3 times a -1, right? Plus 1/2 times 1 minus 6. So negative 1/3 times 27, we're going to get what? Isn't that negative what? Negative 9 plus 9 halves plus 18 here minus negative 1/3 plus 1/2 minus 6. Now, at this point, I might recommend you have 9 plus 9 halves. Just simply, if you like, distribute over here, right? So it's plus 1/3 minus 1/2 plus 6. Okay, so double check here. I want to point out right here, the 9 halves and minus 1/2, isn't that 8 halves, which is 4? So we have 9. Right.
I think it should be isn't it negative 1/3?
Is it negative 1/3?
Multiply negative 1.
Oh, let's double check. You might be right. Let me see. Yes, right over here. This should be a negative. Okay, that's positive, so that makes this a negative 1/3. Good, good. Okay. Are we okay with the rest? You guys know? The rest okay? Sometimes I have to stop talking and writing. Just keep writing here. So 9 halves minus 1/2 is 8 halves, which is 4. So I have 9 plus 4 plus 6 minus 1/3. So it looks like I have 19 now minus 1/3. So let's multiply the top by 3 and the bottom by 3. So what's 3 times 19? Do you guys know? Is that 50? What is that? 57?
Yes.
Okay. So get 57 thirds minus 1/3 gives us, looks like 56 thirds. So there we go. This is how we handle that first situation again, 56 thirds here. All right, you guys okay with that? So the area bounded here is going to be, oops, undo that. This area here is 56 thirds, so maybe I want to erase this portion here. All right. Okay, now let's take a look at this. They want us to find the area between these two curves and over the interval of pi over 4 to pi over 2 now. So notice here, x is pi over 4, and x here will be pi over 2. So let's try to find the area here then. Looks like it's going to be right here. All right, so this is what they want us to find. Now, okay, so let's set this up again so that my area here is going to be the integral of top minus the bottom dx. So we have to identify the top curve and the bottom curve. Okay, so you guys have to know your curves here. Which one's sine, which one's cosine? Or which curve's on top? So if we draw that approximating rectangle here, I have a top, I have a bottom. What curve do you think is on top? Is that the sine curve or the cosine curve?
Sine.
So this is on top, and that means the cosine is on bottom then. Okay, you guys okay with that? So when we replace this, we said the top is sine and the bottom is cosine. So that this will be from pi over 4 to pi over 2 sine minus what? Cosine dx. So we're going to need the antiderivative function. Okay, so what's the antiderivative of sine now? Remember, we're going back up here. Antiderivative of that function minus the antiderivative of the cosine. So what's the antiderivative of sine? Isn't that minus cosine? Don't forget to bring this minus sign here. That's there. Now, what's the antiderivative of cosine? And then just sine. So that's from pi over 4 here. Pi over 2. Okay, you guys okay with that? So here's my antiderivative function. So I have minus cosine pi over 2 minus sine pi over 2 in here minus cosine pi over 4 minus sine pi over 4. So at this point for myself personally, don't know what that was, but I think what I would like to do here is simply simplify by distributing here. So I'm going to drop the first parentheses, and I'm going to distribute the negative signs. That means now it's plus cosine pi over 4 plus sine of pi over 4. So all I did was distribute right here. Okay. So don't forget, this negative sign in front is really like negative 1 times those things. It's negative 1 times that. So do you know what's cosine 90 degrees? Anybody remember?
0.
Is that 0? If you have to, you go back to the curve here. Right? Cosine of 90 degrees is, I believe that's 0, right? What's sine of 90 degrees? 1. Okay, what's cosine of 45? Square root of 2 over what? What's sine 45? Square root of 2 over 2. So at this point, we could just simply say, looks like it's going to be negative 1 plus the square root of 2 over 2 plus another square root of 2 over 2. Final answer would be the square root of 2 minus 1. And I want to point out, the square root of 2 is approximately 1.4. Is that right? So 1.4 minus 1 is about 0.4. In other words, this area here, under that curve that we're trying to find, yeah, that area is going to be the square root of 2 minus 1. It's a very small area. Okay. So that's how we handle 1, 2, and 3. Let's take a look. We can now, let's look at this situation. I want to see this situation. Okay. Yeah, all right. Now the area between these curves, again, sine and cosine over the interval from 0 to pi. So x is 0 is over here. X is pi is right here. So area between the curves. This is what they're talking about. All right, you guys okay with this? So far, so good? Now, I want to point out a couple of details here. You have this intertwining, meaning, you see that point of intersection? We don't know what that value is that right? So there's going to be some value here. Let me go back and point out in red here, we have some location. I don't know what that is, that these curves intersect. So I'm going to call that x for now, because I don't know what that value is. It's a value of x. And when I draw my approximating rectangles, what do we see happening? Top, bottom. The top curve is in blue. The bottom curve is in black. Is that right? And then what happens? They switch, exactly. Top and what now? Bottom. These curves switch. So because your top and bottom curves have switched at the value of x here. Let's get this screen back. Okay, let me show you what I'm talking about. This whole area now is going to be two integrals. Okay, here's what I'm saying. You got a1 plus a2. Where on the left, you have a1. On the right, you have a2. Okay? Everybody okay with that idea? Because these curves just switch from top to bottom. Your approximating rectangle there, will be positive. We're going to have to do this in two pieces now. So the first integral represents a1. That goes from 0 to that x value here. Let me point out. This is from 0. Oops, undo. From 0 to x, I have a top and bottom curve. Now, what's that top curve? It's the blue curve. Bless you. Is the blue curve sine or cosine? Okay. And the bottom curve here is going to be sine. Is that right? Okay. Now, we're going to have to, that's our first integral. This is a1. We're going to have to add a second integral. Now, that second integral is going to be from this x value all the way up to what? Pi. So I don't know that value of x up to pi. And again, I have a top minus a bottom here. But because it's switched, which is now the top curve for the second integral? It's the black curve. Isn't that what? That's sine. And the bottom curve is cosine. This is that second area. The only thing we have to find is what is that x value? And I'll put that in red because it'll stand out, right? So what is x? So remember what we just said. What you have to do, if you ever want to find the intersection of what? Two curves, that point of intersection, you set the curves equal to 0. Right? F of x equals g of x because they have the same y coordinate value. And then what do? You solve for what? You solve for x. So we're going to say that means sine equals cosine. Okay, and so what you guys are looking at now is really a trig function, right? You're solving a trig equation. So you got to go back to 241 trigonometry, solve this trig equation. Anybody remember what you do? In this equation here, you divide both sides by cosine. And you get tangent x, because that's what sine over cosine is 1, and it's positive 1. So tangent x is 1 and it's positive. Which quadrants is tangent positive? In quadrant 1 and quadrant what? 3. Good job. And it happens for what value of x? X is pi over 4. Okay, you guys okay with that? So this integral now becomes we're going to go back and replace this. This x is what we just found. And that's pi over 4. That's right. Let's put it here. So altogether, to find that area, let's write it here. It'll be the integral from 0 to pi over 4 cosine minus sine dx plus pi over 4 up to pi. And then it switches. Sine minus cosine. Okay, take a look at that here. Now, the other value for x, just so you guys know, right? What's the other solution for tangent x is 1? That's 1 pi over 4. That's quadrant 1. 2, 3, 4. Isn't that 5 pi over 4? So I want to remark here. This is the other solution for tangent being 1. Why don't we actually use 5 pi over 4? Because it's not in the interval right here. Is that right? It's outside our interval. Anyway. Okay. So we have two integrals here to perform. All right. So here's what I would probably do personally on this. Let's do the first integral here. What's the antiderivative of cosine? Think antiderivatives now, right? Derivative of sine is cosine. Okay. So we got sine minus, the minus sign is there. Remember this? What's the antiderivative of sine? Negative cosine. Is it important to put negative cosine? Yep. Okay, plus now. So if you want, let's put plus down here. Now, what's the antiderivative of sine again? Is that negative cosine? Okay. So I have negative cosine minus, what's the antiderivative of cosine? Isn't that sine? When you evaluate this from pi over 4 to pi. So notice I have the antiderivative of the first integral, antiderivative of the second integral. So personally, I kind of simplify this all if I can. I have sine x plus cosine from 0 to pi over 4 plus that negative cosine minus sine from pi over 4 to pi. So let's see what we get algebraically here. So I have sine pi over 4 plus cosine pi over 4. This is my first. Minus sine of 0 plus cosine of 0. Don't forget to add minus cosine of pi minus sine pi. Okay. Minus what? Negative cosine pi over 4 minus sine pi over 4. Close that. So be very careful here if I want to point this out. Here's that first antiderivative. Here's the second antiderivative. Okay? Now the first antiderivative, this is the information for the first one. The second antiderivative is over here. Okay? And don't forget that in antiderivatives, we take the difference between those. Okay? So anyway, just want to point that out so you guys can see that. Double check for some mistakes. And there's a couple of ways I think we could do this. Let's actually write it down all together now. Sine pi over 4 plus cosine pi over 4 minus sine of 0, if I distribute, minus cosine of 0. Okay? Now the next line here will be minus cosine of pi minus sine of pi plus cosine pi over 4, looks like plus sine what? Pi over 4. So double check. I notice though my sine of 0, that's 0. Sine of pi is what? Isn't that also 0? Is that right? Cosine 0, what's that value? Isn't that 1? What's cosine of pi though? Isn't that negative 1? Double check because I'm not awake. And it looks like, again, Sine pi over 4, isn't that square root of 2 over 2? Same thing for the cosine. Another square root of 2 over 2, and another square root of 2 over 2. So altogether, it looks like I have, I have what? 1, 2, 3, what? 4. I got 4 square root of 2 over 2's. Minus 1 plus 1. And I think that's it. Is that right? Okay, because I actually have this minus 1 here, and a minus makes that a plus. So final answer is going to be really 2 what? 2 square root of 2. So that's the total area under this curve, and they got intertwined, meaning your top and bottom just switched at a point. They switched at this particular point in red again, right here. And that point in red is pi over 4. So you have to find that location by solving an equation here. Okay, so you have to solve that, and this is the whole process. And I wanted to show you the intertwining, and that happens. So always remember top minus bottom. Is that right? Okay. Notice what they have going on here. Let's see what they gave us here. From 4 to 7 here. So on the left, what do you have? This is x is 4. On the right, this is x is 7. So what you have now is they want area between the curves over that interval. So again, I have a top curve and a bottom curve. I got two separate situations. You have the intertwining. Is that right? And at this value here, the two curves intertwine. They meet, they cross. Is that right? You guys okay with that? So far, so good? So I have two locations here, two intervals. So I'm going to have to find this A1, this what? A2. So my area will be simply A1 plus A2. So we're going to have an integral here, really two. And my first one's going to go from what? 4 up to that x value. And I have top minus bottom again, dx, plus the second integral. That's going to go from that x value up to 7. And I have that top minus bottom again, dx. Okay, you guys okay with that? We need the value of that point of intersection. Does anybody know, by looking at that picture, where do you think that these two curves cross and intersect at? Anybody know what we're talking about? Where do you think they intersect? At 5, is that right? How do we know that that's 5? Yeah. How about if I say, let's note. Let's do something here. How do we find, again, points of intersection? Right? We find points of intersection. Let's note here. We set the curves equal to each other. Is that right? So I'll put this points of intersection. What are my curves? 20 plus x minus x squared. And what does that equal? X squared minus 5x. So remember, you set the two curves equal to each other. And then you solve for x. So algebraically speaking, get your curves on what? On one side, right? I'm going to take all the points, all the terms on the left and put them on the right. So, well, doesn't matter. Let's do the opposite. Let's put these, translate, okay? So here's what you get. 20 plus x minus x squared minus another x squared plus 5x, and that is 0. Negative 2x squared. What's this going to be? Plus 6x plus 20 equals 0. Divide everything by negative 2. You get x squared minus 3x. Is that minus 10? Equals 0. Is that right? Okay, you guys okay with that? Now solve for x. Factor. 5, 2. Right? And what do you get here? Minus 5 plus 2. What does that mean here? I don't have to go through the beginning algebra approach, right? You guys know this means x is 5. And what's the other solution? X is negative 2. So I want to point out to you guys here that yes, 5, and then over here, by the way, that's the other solution. This is where x is negative 2 here. So your curves meet at the value of x of being negative 2 and positive 5. So let's think about this. Which one do we use, the 5 or the negative 2? Why? Because it's in my what? Interval again. Okay, you guys okay with that? So it's in that interval. So what that means here is you don't have to use the other value, but I want to go through the details that algebraically speaking, yes, that's what you would do. Set the curves equal to each other and solve for x. So let's continue here. And let's remember we need a top curve and the bottom curve over the interval now. Let's erase this since we know what it is. Undo. I think our eraser's just too big. Erase the x. Now, for the first integral, a1, that goes from 4 to 5 again. See right here? What's the top curve? The top curve is in black, is that right? So what curve is that? That's the parabola that's opening down. So which parabola is opening down? The first or the second one? Is that F?
Yeah.
Yeah, so let's do this. This is F on top, G on bottom. I can draw the approximating rectangle. And then what happens with the next situation? It reverses. It's G over F. So, okay. So we have F here being, let's fill this in. The top curve, 20 plus x minus x squared. Is that right? And the bottom curve, x squared minus 5x. So let's do the algebra. 20 plus x minus x squared minus x squared minus 5x. You get 20 plus x minus x squared minus x squared plus 5x. We end up with 20 plus 6x minus 2x squared. So that's the algebra for the first integral. Now, maybe we should just put down here, okay, the second integral here. So I need top minus bottom here. And you guys remember it switched, right? So this is x squared minus 5x. And then this will be what? 20 plus x minus x squared. So you'll get x squared minus 5x minus 20 plus x minus x squared. So algebraically speaking, we get x squared minus 5x minus 20 minus x plus x squared. We get 2x squared minus 6x minus 20. So go back here. Let's regroup here. I guess we were going with the blue-green theme. Here's for the first integral. That's the integrand. The second integral is what you see here. Is that right? All right, you guys okay with that?
Yes.
All right, now, should we erase all this work here for the points of intersection? You guys already have that in your notes. It'll be in the video. Choose a big O eraser. Right, we already know what that is. Okay. So let's set this all up. 4 to 5. So I have to integrate from 4 to 5. 20 plus 6x minus 2x squared dx plus 4 to 7. That's the next integral. Or I'm sorry, 5 to 7. Two x squared minus 6x minus 20 dx. Okay. Two integrals to perform. So, if you want, call this A1, call this A2. Here's what we get. 20x plus 6x squared over 2 minus 2x cubed over 3. And that's from 4 to 5. Plus 2x cubed over 3 minus 6x squared over 2 minus 20x from 5 to 7. Let's simplify. 20x plus 3x squared minus 2/3 x cubed from 4 to 5 plus 2/3 x cubed minus 3x squared minus 20x from 5 to 7. So we're going to have two of these to do, so let's do them separate. How's that? So maybe we'll do this here in blue. And the other one will be done in maybe green. I don't know. So if you guys can see everything here. All right. Okay. 20 times 5 plus 3 times 5 squared minus 2/3 times 5 cubed minus 20 times 4 plus 3 times 4 squared minus 2/3 times 4 cubed. Let's get that answer here. So looks like we're going to get 100 plus 75. Is that right? 3 times 25 minus 2/3 times 125 minus, let's distribute and compute at the same time. Minus 80 minus 16 times 3. Is that 48? Minus 2/3 times, does anybody know what's 4 cubed? And is that minus or plus? Plus 2/3 times 4 cubed. What's 4 cubed? Isn't that 64? Double check. I'm not awake. All right, thank you. All right, let's do some arithmetic here. 175 minus, let's put the whole numbers together. 128 minus 2/3 times 125 plus 2/3 times 64. Let's see what we do there. What's 175 minus 28? Isn't that, if it was, let's see. Is that 47? Anybody know what I'm talking about? Is this 47 here for the whole numbers? And then I'm going to factor out here my 2/3. And I really have 64 minus what? 125? So what's that difference going to be? What's 64 minus 125? Let's get 47 plus 2/3 times a negative 61. Is that right? Yeah. Okay. That's still not divisible by 3. So it looks like here this is going to be 47 minus 61 times 2. Is that 122? Yeah. Over 3. So multiply this top by 3, bottom by 3. And we get 3 times 47. What's that? 120? 141. So 141 over 3 minus 122 over 3. Anybody know that difference? 19 over what? 3. There you guys go. 19 thirds. That's just the blue integral. Let's do the green now. So in green, let's see if we can write this down here. We have 2 thirds times 7 cubed minus 3 times 7 squared minus 20 times 7. Doesn't seem to want to write. Minus 2 thirds times 5 cubed minus 3 times 5 squared minus 20 times 5. Okay? All right, you guys okay with that? Double check that in green here. Doesn't that make doing your homework when it was all in, what color? I'm sorry, what value? When you had the zeros, isn't that pretty nice? Anybody look at that, how zeros are nice? Yeah. Okay, so we're going to have to know, what is 7 cubed? Do you guys know what 7 cubed is? 7 times 7 is what? 49. What's 49 times 7? 343. Minus 3 times 49. Minus 140. Let's distribute. That's 125 plus 3 times what? 25 plus 100. Now 3 times 25 we know is 75. Let's see what we can do here with these. So I get, this is going to be 2 times 343. Do you guys know what that is? 686, right? 686 over 3 minus 49 times 3. Is that 147?
Yes.
Minus 140. Minus, it doesn't, can 3 go into 125? No. So that'll be 250 over 3. Plus 75 plus 100. So let's bring all our whole numbers together. Well, we can do the fractions first, right? So what's 686 thirds minus 250 thirds? Isn't that going to be 436?
Yes.
436 thirds. And I'm going to do this. This is minus 287, right? Plus 175. So I get 436 thirds now. Minus, what's the difference there? Do you guys know? 2. Is that 112? And multiply your top by 3, divide the bottom by 3. So in green here, we get 436 thirds minus, I don't know what's going on there. Got to get rid of that. Okay, let's do it again. 436 thirds minus 336. Is that true?
Yes.
So that's going to be, what is that?
100/2.
No, that's the second integral. 100 over 3. So altogether, you say, well, what do I do here now? Well, altogether, I take the 19 thirds that we got over here, and I add it with our what? 100 thirds to get 119 thirds. Okay? So that's the kind of work you guys will have here with some of these area between curves now. Pretty good questions. Now, this leaves us at number 6, but what I think I want to try to do at this point, right, I'll go back and do some of the others, okay, from 6, because I think, again, you guys see the point here. Do you guys see this point? I mean, we could try this one, but, yeah, let's try this one here. Let's do number 6. It's not that big of a deal. Let's try this out. The area between the curves over that interval. See that there? Now your interval again is between negative pi over 4 to positive pi over 4. So on the left you have what? Negative pi over 4, positive pi over 4. And we need to identify the what? Top and the what? And the bottom. Is that true? So this is going to be, if we integrate from negative pi over 4 to pi over 4, top minus bottom dx. What's your top curve? Can you guys identify the top curve? Yeah, it's 2. It's not the secant. It's in blue. Can you guys see what's on top? So this is going to be 2, and this is what? Secant. Okay, this is the top curve, and this is the bottom curve. So we're going to integrate from negative pi over 4, positive pi over 4, 2 minus what? Secant squared dx. Now what do you get? We need the antiderivative, right? So what's the antiderivative of 2? 2x minus, what's the antiderivative of secant squared? Tangent, good. This is from x is negative pi over 4, positive pi over 4. Antiderivative. So we need f of pi over 4 minus f of minus pi over 4. Okay, let's see what that looks like. 2 times pi over 4 minus tangent of pi over 4 minus a what? 2 times negative pi over 4 minus tangent of negative what? Pi over 4. So we get here, when we simplify our fractions, pi over 2 minus tangent pi over 4. Minus and minus makes that plus. Plus another pi over 2. Plus tangent of negative pi over 4. Double check. Do we have a minus and minus there? Looks like we do. Okay, see how we distribute the sign? Anyway, pi over 2 plus pi over 2, and let's do a couple of things. Is tangent even or is tangent odd? That's odd, is that right? So I'm going to say this. This is tangent of what? Pull out the negative sign since it's odd. So altogether, if I simplify a few things, pi over 2 plus pi over 2 is going to end up giving me what? 2 pi over 2, or just simply pi. Pi minus tangent pi over 4 minus another tangent of what? Pi over 4. And so if you wanted, you can say pi minus 2 tangent pi over 4. Combine your like terms. What's tangent pi over 4 again? Square root of 2 over 2? Pi minus 2 square root of 2 over 2, or simply pi minus the square root of 2. Now notice pi is about 3.14, square root of 2 is about 1.41, so the difference is positive, right? So your area under this curve here is kind of interesting. Yes, you took top minus bottom. That area is pi minus the square root of 2. Difference between two irrational numbers. Anyway, okay, good. Okay, look at number 7. They want us to do 7 using some geometry. Because if you could do this actually using calculus. And in this question here, even though they said, let's highlight this, they said use geometry. Now, what do you think that means, geometrically speaking? What picture do you have here? What's the area of a circle? Isn't that pi r squared? What's your radius in this case? Everyone know the radius value? Isn't that 2? You say, how do I know? Because that's 2, that's 2. Okay, you guys okay with that? So we can have pi times 2 squared, or the area will be 4 pi. Here's our area. So that's just simply using, with that 2 radius here, geometry. Now, you might say, what about calculus? Well, calculus comes along and says, I want area, what? Between the two curves here. And I need an approximating rectangle again. I'll put it over here now. So I have a top minus a what? Bottom curve. Now the top curve, ladies and gentlemen, is this first function. It's the square root 4 minus x squared. The bottom is in blue. So what you can do to find area, it'll be from negative 2 to 2. Top minus bottom dx. Remember, the top curve was what? Minus square root 4 minus x squared. The bottom, oops, I got it backwards. The bottom was the minus curve, 4 minus x squared. Right? So altogether, that's going to be from negative 2 to positive 2, square root 4 minus x squared minus, go back, minus a what? Minus. Makes that a what? Plus. And so your area here will be negative 2 to 2, 2 square root 4 minus x squared dx. Now I'm going to say to you guys, you don't know how to integrate this in this particular class. Okay? In this class, you have to take the second calculus course. So, Math 262, the second calculus course covers this. So you guys know. But you already know the answer, and they assume you guys have had some geometry. You know the area of a circle formula, pi r squared. So that's why they said use what here? Geometry. But it can be done by calculus. You just have to wait for the next course to see techniques to how to integrate this. It's called trigonometric substitution. This is one way. Another way would be to convert this to polar form, and we'll do that too. So stay tuned. Yeah. So, yeah, let's do the right minus left now. Do you guys want to do some of those? Let's try to find them here. So we give you guys some of those examples. But I'll go back and finish some of this stuff, this video is for you guys. And I believe the worksheets are online. So if you guys didn't know, I put the worksheet online for this so you guys see these questions. But how you answer your homework questions out of the Stewart book is the same way. So this is kind of lecture examples if you want, and then in the future it might be homework for future calculus classes. They get to do both. So let's find the left minus right. I mean, I could do this question here. This is interesting. I want to try this one, but I want to try them all. But let's try to find some. Oh, let's do this one. Wow. Do we have time? Yeah, we got to do some of these. Yeah. Let's see. Let's 9. What else do we have? Yeah, I want to do a couple of these here. Okay, let's do a couple of these here first. Yeah, but then if we have 8, you think we could do that quickly? Huh? Actually, no, we have to do this one. Let's do this one. I apologize. Notice this. What's the interval? 0 to 2 pi. So over here, x is 0. What's this? X is 2 pi. So let's remark here. We have this area to find, this area, and then that last area. Is that true? But notice something here. You have what? You have 2 points of intersection in that interval. That's some x value. And it looks like this is a little bit to the right here. That's another x value. So far, so good? Okay, do you guys see what I'm talking about? So this is a good question to work on. The question is, what are these values? Well, how do you guys find points of intersection again? So remember, the points of intersection. We should probably put it in, let's put it on the next page here. You set the curves, what? Equal to each other. Sine x is cosine 2x. So let's set those curves equal to each other. And then you solve for what? You solve for x. Is that right? Okay, does anybody know how you solve this trig equation? Do you guys remember this one? How you solve this trig equation is you use a special identity because they have different arguments, meaning what's inside here, this is just x, and this is 2x. So I can't do what I did before by divide both sides by cosine 2x. Okay, because that gives you sine x over cosine 2x equals 1. That might be true, but that doesn't now mean we have tangent x is 1. So this is a special situation. Here's what I'm saying. If you guys remember, what do I replace cosine 2x with? There's a trig identity here. What trig identity do I use here? Do you guys remember? Cosine 2x. There's a nice trig identity. Let's see if we can find it for you guys. It's a double angle identity. You guys know what that one is? Cosine 2x? We have a couple of them. What do you guys use for that one? We have sine 2x, we have cosine 2x. So which one do we use here? You know what we could use? This is going to be 1 minus 2 sine squared x. So we can use that one. And I say here sine x equals 1 minus 2 sine squared x. So what do you guys do now here? We can translate this term, I guess, right? Oops, if I can get some, boy, that's weird. Translate, and what do we get now? We get 3 sine squared x is what? Is that 1? Is that true? Double check. Is that okay? So that means sine squared x will be 1/3, or it means by the square root formula, sine x is plus or minus square root of 1 over 3. Is that right? So this will mean sine x is plus or minus 1 over the square root of 3, or it means what? Yeah.
How did you get 3 sine squared x?
Oh, if you're going to use the trig identity here, 1 minus 2 sine squared x, okay, you're going to use this here. See that there? So if you translate, add 2 sine squared x to both sides. Oop, I made a mistake. Good. Ah, no wonder it wasn't coming out. Thank you. Ooh. You get 2 sine squared x. Thank you. Plus sine x equals 1. I'm so much in a hurry to finish all these to get to the other. Anyway, okay. Sorry about that. And then translate the 1 if you want. All right. 2 sine squared x plus sine x minus 1 equals 0. Okay. Do you guys know what you do now with this? Here's what you guys do. You're going to let t be, you're going to do a substitution here. You let t be sine x. Okay? So here's my t right here. That means I got t squared there. So you have 2t squared plus t minus 1 is 0. And solve this for t. It's a quadratic. 2t is 0. Solve that quadratic. You're going to let that be t, and this becomes your t squared. How do you get that? By factoring here, right? You got a 1, you got a 1. This is plus, and this is what? Minus. Is that right? So I guess we're going to have to do that t. 2t minus 1 is 0, or t is actually 1/2. T plus 1 is 0, or t is negative 1. Now t is going to be what again? Sine. So this means Sine is 1/2. And what's the other solution? Sine is what? Is -1. So, where is sine 1/2? Do you guys know? So let's double check. We're looking for 0 to 2 pi solutions. So sine is 1/2. So let's go back here and let's consider. I already know here, -1 for sine, where does that happen? Is that 3, what is that? Is that 3 pi over 2? Is that 3 pi over 2? Double check because I'm not awake. Right? Doesn't it happen at 3 pi over 2? I believe so. So that's right here. Okay, this is the x value you just found. The other value we have to get now, because this is from 0 to 2 pi, so that's 270 degrees. So sine is positive in what quadrants? All students, 1 and what? 1 and 2. So we want to find the special triangle here. If we go back, here's t. What's the definition? What's the definition of sine here? Let's change this color. That's opposite over what? Hypotenuse. So opposite side is 1, hypotenuse is 2. What's the angle down? What's the adjacent side? Is that square root of 3? I believe so. What angle for t is this, by the way? Remember this triangle? 1, 2. What does that mean t has to be? Is t, this is a special triangle. This is your 30, 60, 90. Is that right? 30, 60, 90 degree triangle. So what does that mean about t? Is t 60 degrees or is t 30 degrees? 30 degrees. Is that right? So how do we write 30 degrees? Pi over what? 6. Ladies and gentlemen, there you go. Okay, so I want us to at least set this up for you guys. Pi over 6 here. So I'm going to have, let me go back. Can I erase the shaded part at least? You guys get that point?
Professor,
Yeah.
is 2 pi between 2 and 4?
Say that again.
2 pi is between 2 and 4.
2 pi is here. 2 pi is over here. 2. Is that 6? That's about a 6. Maybe that line is not good. This first red line. Uh-oh. Good answer. Okay, let's double check here. It looks like it's going to be about 6. So this is 2, 4. The question is, where is about 6? So you got 1. Okay, here's 1, 2, about 3, 4, 5, 6. Yeah, let's just change this to be, what is this here? Pi. Okay, you guys okay with that? That's a good observation. Thank you for being awake. That should be pi. All right, you guys, good observation. We're going to make that pi. We don't want to complicate our lives and get 5 integrals. Okay, you guys okay with that? So we're only going to have this integral right here. Good observation. So I say note to self, change this to pi. But if I change that to pi now, yeah. Uh-oh. I have an issue here for this one. Pi is about 3. So it looks like this is pi, but what does that mean about our solution here? Sine, go back here. Sine is -1. Is that true? You guys okay with that? Where does sine, is that happen at 270 degrees? I have a problem here. Anybody see what I'm talking about? The question is, what's this angle here? Yeah, okay. That means this is not 3 pi over 2. Okay, you guys okay with that? That's not 3 pi over 2 then. That's going to be here. We have to throw this. If we're going to use pi, we got to throw this one out, because that's outside of the interval. But this quadrant 2 solution here, remember the quadrant 2 solution? Pi over 6, all students, what's that going to be then? Do you guys know how to get the other solution? Remember this, all students take calculus, right? So let's clear that out. All right. All right. Let's go to the quadrant 2 answer. So let's note. I'll do it right here in blue. All students take what? Calculus. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So you found the first quadrant here being pi over what? We'll put it here, pi over 6. So that means the second solution here, I think our eraser's still too big. It means the second solution is over here in quadrant 2, because this is where sign is what? Positive again. Remember that? All students take calculus. So, what does that mean? That means my reference angle here is pi over 6, right? So for the second solution, this angle here is what we're trying to find. Do you guys remember how to find that? It'll be pi minus pi over 6, which will be now 6 pi over 6, which gives you now what? 5 pi over 6. There you go. That's the solution. Good. So now we're in business. 5 pi over 6. So as you guys can see, yes, there is some work to do just by setting this one up. So at least we'll set this one up. Now it looks fine. Now we're perfect. So note to self in number 8, you got to change that integral for pi. We have how many integrals, though, to set up? Right? I got an approximating rectangle over here. I got an approximating rectangle over here. And I got an approximating rectangle over here. So I have a top, bottom, top, bottom, top and what? And bottom. Okay, so there's going to be 3 integrals. You guys ready for it? Here's my first one. I integrate from 0 to pi over 6. What's the top? They got top minus bottom. What's that top curve? What's the blue curve? Cosine 2x. What's the bottom curve? Sine x. So this particular integral will be 0, pi over 6, cosine 2x minus sine x dx. So that's my first one. I have to find the next one. And I'm going to integrate now from pi over 6 to what? 5 pi over 6. So notice this particular interval now. This is from this point up to this point. And what happened with the curves? Didn't they switch? I still have top minus bottom, but they switched. The top curve is sine, and the bottom is cosine of what? 2x. So the second integral is going to be, I don't know what that is. There we go. Pi over 6, 5 pi over 6, sine minus cosine of what? 2x dx. We need the third integral. So for the third integral, let's focus on this. We're going to go from those 2 points, from pi to 5 pi over 6, really. So for the third integral, 5 pi over 6 up to pi. Top minus bottom. And what happened in this situation? The blue curve is on top again, which is cosine. So we switched. This is cosine of 2x, and this is what? Sine of x. So the last integral will be from 5 pi over 6 to pi. Cosine 2x minus sine x dx. So let's emphasize here in purple here. All right, let's find blue. We're going to integrate that integral. We're going to add it with, I think that's kind of distracting personally. Choose the gray. This integral plus this integral plus what? That integral. We'll at least set it up for you guys. So you have 3 integrals here for this kind of situation. Okay, you guys okay with that? So I wanted to go through that one too. So 0 to pi over 6, and then pi over 6 to 5 pi over 6, then 5 pi over 6 to pi. So that's actually a pretty good question, so you guys know. Okay, and I won't finish that integral. I'll try to go to the others here, because there's a lot of good stuff to do here. There's tons. This is a similar situation. What I can do is maybe help set this up for you guys. Or what we can do is look at the left and right. Maybe we should try that, left and right. Set this one up. They have, 3 points of intersection. Okay. Let's do some left and right. Here you got points of intersection again. Okay. So let's go through and find a nice left and right situation. Here you got 3 points of intersection. You set the curves equal to each other and solve for x. Yeah.
There's no interval, there's always boundary region.
Yeah. Yeah, if they don't give you an interval, they're going to make sure your curves cross where you do some algebra. Like this one here is a nice one too. I mean, here's what I want to remark is that you got here and here, and when you set the curves equal to each other, you're going to find that point of intersection, that point of intersection, that point of intersection. You got 3 points of intersection. And you got 2 different integrals because they intertwine again. So I wanted to go over that intertwining here. But I do want to get to, this one's even really good too. We could just set it up, I guess. They want area between curves here, and maybe this is a good one to talk about, just to at least set up. Because they give us these lines, y is pi over 6x and y is pi over 3x. We have to find, maybe I'll just change that color here. Find this bounded area. And I want to point out to you guys something is happening here. We have 2 integrals again. We don't know that value of x. So if we can set it up, and hopefully we can, you might say, how do I get that value of x? Right? We need that point of intersection. In fact, we need another point of intersection here. And this is what would happen for this particular one. If you guys notice, this one's kind of interesting here. What's that point of intersection? That looks like it's 1. Is that true? So I don't have to do much algebra there. But how do I find that first point of intersection? You got 2 of these here. Right? Points of intersection again. We set the curves equal to each other. Now, what do you think that is? How do you think we get that? So the first one in black here, right, isn't that going to be what curve? Cosine x is going to equal, and then what's the red curve? Pi over 3x. We have to find that value. What is x? This one's going to take some numerical work here to solve something like that. Okay, because you don't really have a way to solve this very easily. So this one, you're going to have to use some numerical technique. So, I took this from another book, but how you would handle that is use a numerical technique to determine that x value. Anyway, let's find the left and right. So I want to kind of just abbreviate that kind of. Oh, there we go. This is what I'm looking for. Okay? So notice this here. They give you here for number 15. X is a function of y. X is another function of y. Okay, you guys okay with that? And this is bounded. They don't give you y over an interval. So you have a point of intersection here and another point over here. So we're gonna have to find now these horizontal lines for these points of intersection. So this is the point y equals c, and this is the point y equals d with the information we gave you. And they want this area here. So I want to draw now not a, can't see this here, not a what? Not a horizontal strip, but a vertical strip. And so here's my right curve, here's my left curve. So remember when we said let's find this integral here, well, you're going to integrate from what? Not top minus bottom, but right minus left. And now this is going to be that dy for you. The question is, what are the limits? Okay, you guys okay with that? Now, what's the right curve anyway, just so we know? Isn't that the line? And what's the equation of the line? This is going to be that x equals some function like g of y. Here's x of f of y. So this is going to be replaced with 3y plus 8, and the left curve is y squared plus 4y minus 22. So algebraically, you have 3y plus 8 minus y squared plus 4y minus 22. And if we remove the parentheses or distribute, 3y plus 8 minus y squared minus 4y plus 22. So when we simplify and combine like terms, what do we end up with? Right? I can put minus y squared first, and then 3y minus 4y is minus y. 8 plus 22, isn't that plus 30? So this integral again will be minus y squared minus y plus 30. Make sure I did my arithmetic okay. And this is all dy again. I don't know why it does these funny symbols. Doesn't seem to like that spot. Minus y squared minus y plus 30 dy. We just need our limits. Lower limit would be d, upper limit is c. We need that value c less than or equal to y, less than or equal to d. And I think I have it backwards. Sure do. C to d. Okay? This was c to d again. Just be careful here. How do we write this? If I go through, if c is low, okay, this has to be, to fix this, this has to be what your c, and this is d. Okay? There we go. Now we're c to d, lower minus upper. C, d. Okay? So notice here we have right minus left. So at this point with this particular integral, right minus left, we need the points of intersection. So you might say, how do you get those points of intersection? Well, you set the curves equal to each other. So this time x is f of y, x is g of y. So you say, okay, f of y equals g of y, and then you solve for y. So you set the curves y squared plus 4y minus 22. And that will equal 3y plus 8. So I get a quadratic equation in terms of y. So I'm going to subtract my 3y from both sides. Subtract my 8 from both sides. So I'll get y squared minus y minus 30 equals 0, a quadratic factor.
Plus one.
So plus y, you're right, plus y, good. 5 and 6, is that right? So it's like it's plus 6 minus 5. So that means, what does that mean? Double check if we factored okay. That means y is 5 and y is what? Negative 6. These are my two solutions. Okay, so negative 6 and 5. So go back over here. Ah, sure enough, that's what? That's negative 6. And the other one is positive what? 5. So we could have seen just by looking at the picture that that was negative 6 and 5. Is that right? Did you guys see that right here? See this point? If this is negative 5, that's negative 6. And if this is here, we know this is 5. So we're going to replace our C and D here with negative 6 to what? To 5. So what you guys would do here is you'd integrate this one, find the antiderivative here. And what does that give you? Let's see. Let's try it here. Negative 6 to 5, negative y squared minus y plus 30. So we get negative y cubed over 3 minus y squared over 2 plus 30y. You evaluate this between negative 6 and 5. So this is my f of y here. So we'd have to find f of what? 5 minus f of negative 6. So let's plug this in. Negative 5 cubed over 3 minus 5 squared over 2 plus 30 times 5 minus negative 6 cubed over 3 minus negative 6 squared over 2 plus 30 times negative 6. Negative 125 cubed minus 25 squared plus 150. I'm going to leave the parentheses here because this will be negative 216. Is that negative 6 cubed? Is that 216? Double check. Is that going to give you a positive 216? Okay, you guys okay with that? Minus 36 halves minus 180. So I get negative 125 cubed minus 25 halves plus 150 distribute minus 216 over 3 plus, I'm going to keep this halves, 36 halves plus 180. So that I'll combine my cubes first here, okay? Isn't that negative? What's negative 216 plus negative 125? Negative 341 cubed. And then negative 25 halves plus 36. Isn't that going to be plus what? Is that 11 halves? What's 150 plus 180? Isn't that plus what? Is that 330? Okay, now we need to have what? Like. Don't these have to be like? What's the LCM of 3, 2, and 1? Isn't that 6? Times 2 times 2 times 3 times 3. 6 and 6. What does our arithmetic give us? Is that 682 over 6 plus 33 over 6? Double check. And then what's 6 times 330? Is that 1800 plus another 180? Is that 1980?
1980.
Okay, what do you guys get here? 1980 plus 33 minus 682. Okay, this is over 6. What do you guys get?
1331.
What is it?
1331.
1,331. And I don't think that's divisible by 6, but okay. Now this is the area here, 1331 over 6. But this is a classical method here where you have the right minus the left now. Okay, so I at least wanted to go through something like that for you guys. But as you guys can see here, you got another one here. It's kind of interesting. Point of intersection here, point of intersection over here. Is that right? And if you guys take a close look at the curve and the graph, because you're given x equals one function, x equals another function. So you're given here, x is some function f of y, x is some function g of y again. You want the bounded area. You need this what? This here. So we have y equals c, y equals c. What do you guys think you're going to get for these values here? I think y is -2. And what do I think about the other one? What's y here? +2. So you might say, Mr. Judge, how do I do that? Set the curves equal to each other? Solve for y. I just need to know what's my right curve and what's my left curve. Okay, so what's the right curve, ladies and gentlemen? Isn't this one on the right? X equals 3 minus y squared. Is that true? And then what's the other curve? X equals y squared minus 5. Is that right? Do we have that okay? It looks like that's the left. Let's double check. Looks that way to me. So your area will be from -2 to +2, right minus left, dy now. So -2, let's actually do the algebra first because we don't want to keep writing all that stuff down. What was the right curve again? Isn't that 3 minus y squared? And the left curve was y squared minus 5. So it's from -2 to +2, and you get 3 minus y squared minus y squared minus 5. Let's do what I actually mentioned. Let's just do the algebra. So that gives you 3 minus y squared minus y squared plus 5, or we end up with 8 minus what? 2y squared. So we're going to integrate here from -2 to +2, 8 minus 2y squared, and this is now dy. Okay, you guys okay with that one? Should we finish this one off? Let's finish it. 8y minus 2/3 y cubed from -2 to +2. This is my f of y. We need f of 2 minus f of -2. Let's do some arithmetic. 8 times 2 minus 2/3 times 2 cubed minus 8 times -2 minus 2/3 times -2 cubed. 16 minus 2/3 times 8, that's in my first parentheses, minus a -16, looks like that's plus 2/3 times 8. Is that true? Double check. Negative, okay. So I'm going to just remove my parentheses and distribute. So it looks like I got 32 minus 4/3 times 8. Is that right? Because I combine these two terms and then these two terms. And that's going to give me 32 minus 32/3. Double right. Is that 4? Yeah, it's 4/3, right? 8 and 8 is 16 is 32. Double check my arithmetic, okay? So I get, looks like it'll be what? 96/3 minus 32/3. What's that difference going to be? 64 thirds. There you go, ladies and gentlemen. So this area here is 64 what? Thirds.